welcome back again. The topic today is binary search. So let's take an example of an array. Array is equal to 1, 5, 7, 10, 11, 13, 15, 20, 25, 29, 35, 32. For binary search, the difference between linear search and binary search is for binary search, you search one after the other until you get to the item you want to search for linear search. But for binary search, is always binary. That you divide the array by 2 from the middle point. Is that understood? That is the difference. And also, before you can use binary search, the array must be sorted. So you can use insertion sort or bubble sort to have sorted your array before binary search can be used. If the array is not sorted, then you cannot use binary search. Is that understood? Okay, good. Okay, so I have 35, 32, which means this is not sorted. It should be 32 and 35. Okay, good. So the principle is, let's take, for example, we want to search for, this is the index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we want to search, I'll search for 3 values. One value that will tend to the left, one value that will tend to the right, and one value that will not be found. Or let me say 4, 2 values that will not be found. So let's take, for example, we want to search for a 4. So while doing this illustration, we will understand the algorithm and how to write the algorithm. Because before you solve a problem, before you write an algorithm to solve a problem, the first thing is to understand that problem. Once the problem is understood, then it is easy for you to solve that problem. So let's understand this problem. We know binary search means dividing the array into 2 parts from the center. So let's assume we want to search for a 4. To search for a 4, what does that imply? We have to find the center value, the mid value. Is that understood? How do you find the mid value? The first thing is what? Is to know the first index, isn't it? So the first index, let's assume it is first, is equal to 0. And the last index is equal to what? 11, isn't it? So we can say the last index is the length of array. We can also use length of array minus 1. Both are correct. It depends. With this is the last index. With this is not, no, this is not the last index, but this is the last index, isn't it? So, but you can use any of them. It depends on how you want to write your algorithm. Is that understood? So let's use any one that we are comfortable with. Let me use this one because this one is kind of easy. Let me use yours that is not as easy as this, so we can learn from that. Okay. So the last is length of array, and the length of array is what? Is 12, isn't it? So that means the last should be what? Should be 12. To find the mid is always what? The first plus last floor divided by 2. This is wrong because it will follow the rule of precedence of operator. Is that understood? It will first divide last by 2 before adding it to first. Is that understood? So if first is not 0, then it will be wrong. Is that understood? Let's take, for example, 2 plus 12, floor divided by 2. 12 divided by 2 is what? Is 6. 6 plus 2 is what? Is 8. But 2 plus 12, floor divided by 2. 2 plus 12 is what? 14. Divided by 2 is what? 7. Can you see? There are 2 different values. So you must understand the mathematical relation before you start adding. So which one do you want to use? It is the one with bracket. Is that understood? Now, so that means the mid is this. So according to, if we use last as length of array, so that means mid in this case will be equal to 0 plus what? 12 floor divided by 2. So the mid is what? Is 6. Is this 6 the mid index or the mid value? The mid index, not the mid value. So a lot of students think that that value is the mid value. No, it is not the mid value, it is the mid index. Is that understood? So the mid index is 6. So this is the mid index. Don't forget, this is what? This was the first and this was the last index. Is that understood? Or this was the first value, this was the last value. Why this mid is the mid index, which is 6. So 15 is the value at the index. So the value we want to search for is 4. So we compare this 4 to the mid value, not to the mid index, to the mid value. A lot of students will compare 4 to 6 to mid. Mid is an index, not the value. The value at the index is what? Is 15. Is that understood? So if you compare 15 to 4, is it equal? So first you check the equality. You check target, which is the search value, target, if it is equal to array mid. So can you see we are developing the algorithm while we are understanding the analyzing the question. Is that understood? When we compare 4 with 15, is it equal? No. Then we'll now try to check if it is less than 15 or greater than 15. Okay? Since it is not equal, if it was equal, then that is the value. Is it equal? The answer is no. That means that is not the target value, isn't it? The value is not found yet. Then we will now check if what? If the target value is what? Greater than array mid, or if the target value is less than array mid. So if you look at this target value, which is 4, is it greater or less? It is less. If it is less, that means that the value we are finding should tend towards the left. Is that understood? So that means we don't no longer need all the values at the right. It's none of our business any longer. Is that understood? So now that means that since we only consider this left value, that means the first still remains 0. But what will change? The last will change, isn't it? The last will change. So last is no longer what? Length of array. Last will now be equal to what? The value before the mid, isn't it? Isn't it? So this will be the last index. The value before the mid. Is that understood? So this should be the last index. That means that last is now equal to what? Mid minus 1. Yes or yes? Good. Then this should be the last. This is the first. This is the last. So that means if the target is less than array mid, last is equal to mid minus 1. Is that understood? Is that understood? So that is last. So now that is last, then we will calculate the middle index. We will calculate the middle index. So that means the middle index now will now be 0 plus, because the first is still 0, isn't it? So that will be 0 plus what? 5, 4 divided by 2. Is that understood? So 0 plus 5, that should give me what? That should give me 2. So that means the middle index is now 2. This is now the middle index. Then we compare 4, that target value, with the middle value. Now we are at this point of this algorithm. Comparing 4 with what? With 2, isn't it? Is it equal? No, it is not equal. So that means that is not the value. Since it is not equal, what do we check? We check if it is greater. Is it greater than that value? No. Then we check if it is less. Is it less? Yes. Since it is less, that means we no longer need everything at the right of that. We only need the one at the left. Is that understood? So that means that the first still remains the first, but the last what will change to the value before the middle index, right? And what is the value before the middle index? Mid minus 1 again. So this is last. So mid is now equal to what? 1. Is that understood? Sorry. Last is now equal to 1. Is that understood? The value before the middle index, because when it is less, last is equal to what? Mid minus 1. Okay? Now we will calculate the middle index. First remain first. That should be what? 0 plus what? 1. 4 divided by 2. And my answer is what? 0. Is that understood? Is 0. That means the middle index is now 0. Since it is index 0, the value at index 0 is what? Is 1. Then we compare 4 with what? With that value, isn't it? When we compare 4 with that value, is it equal? No. Since it's not equal, then we check if it is less or greater. Is that understood? If it is less, is it less or greater than that value? It is greater. So now that it is greater, that means the value tends towards the right, no more the left. Is that understood? Is that understood? It only tends towards the right. And what is the value at the right? That means that the first will now change, the last will remain the same. Because since target is greater than that value, that means that what? First index will now be equal to what? The value after the middle index, which is equal to what? Mid plus 1, isn't it? Is that correct? The value before the middle index. Sorry, the value after the middle index will now be the first, isn't it? So that means the first is now equal to what? Is equal to what? Is equal to last. So now that first is equal to last, what does that imply? That implies that you are done with the array. You can no longer search any other place. It's checked, but it means we are done. So let's check. Is that understood? So first is equal to last. So what would you calculate now? We will calculate the middle index again, isn't it? Don't forget that first is now equal to what? Last. Are you all following me? First is now equal to last. Then we calculate the middle index. So what is the middle index? The middle index is what? 0. It should now be 1. 1 plus what? 1 divided by 2. So the middle index should be what? Should be 1. Is that understood? Good. Good. Now that mid value is now 1, then we'll compare the target value with the mid value. Is it the same? No. But we need to check to the right or left again. So at this point, we don't check to the left or right because the first is now equal to the last. Is that understood? So once the first is equal to last, that means the array has been completely searched. So we don't have to continue the search function. Is that understood? Good. So now, this value is a value that tends towards the left that is not in the array. So let's now search for, let's say we want to search for 40. Is a value that is not in the array, but what? Tends towards the right. So we've gotten a condition where we stopped initially, where first is equal to what? Last, isn't it? That was where we stopped searching. That means we are done searching the array, whether the value is found or not. Once first is equal to last, that means we've combed all through the array. Is that understood? Now let's search for 40 and see what that will give to us. Now let me clean all this to make my work easy. Now to search for 40, like I told you guys, the first thing is to identify the first index and what? The last index. Our first index is still what? 0. And the last index that we adopt here is still what? Length of array. Is that understood? It's still length of array. So what is the mid? The first plus last, so divided by 2, isn't it? Then that means that what is the first? 0 plus the last is what? 12. 4 divided by what? 2. That means the middle index is what again? 6. Is that understood, everyone? So the middle index is 6. Then we compare 6 to 40. Is it the same? Is it equal? It's not equal. But is it more than the target? Is target more than the value at the middle or less? It's more. That means that value tends towards the right. So we have to ignore all the value at the left because that value tends towards the right. Is that understood? So now that it tends towards the right, that means it's what? It's greater. So what do we change? Do we change the first or the last? Only the first, we don't change the last. Is that understood? So the first is what? The first is mid plus 1, isn't it? So this will now be the first index first. Is that understood? Then we will calculate the mid. We're calculating the mid, that is first plus last, plus divided by 2. So what is first now? First is 7. And last is what? 12, isn't it? So 7 plus 12 is 19. Divided by 2 is what? That should be 9. 4 divided by 2 is 9. So it means now the middle index is now index 9. Is that understood? Then we now compare that value with what? With the target. Compare target without the middle value. Is that understood? Is it equal? What does that imply? The value tends where? Towards the right. Because once it's not equal, then we check, is it greater? Yes. Since it's greater, that means we ignore all the value at the left. What is now the first? The first is now the value after the middle index, isn't it? So the value should the first should now be what? Should now be 10. Is that understood? So let's calculate the middle index. We calculate the middle index, that should be what? 10 plus 12 divided by 4 divided by 2. And that should give me what? 22 divided by 2 is what? Is 11. Isn't it? So 11 is my middle, is now my middle index. That is, the index 11 is now my middle index. Then I compare this 40 with that middle index. Is it greater or less? Is greater. The target is greater than the middle value. Is that understood? So now that the target is greater than the middle value, am I supposed to continue checking? Okay. Let's do it this way. Yes, we need to check to the right, isn't it? If we want to check to the right, what should be the first? First should be what? Mid plus 1, isn't it? So if fourth is equal to mid plus 1, that means first is now greater than the last. Is that understood? You understand what I'm trying to say? That means first is now what? Greater than it what? No, wait. First is now equal. If first is mid plus 1, that means first is now equal to 11 plus 1. And what is last? Last is 12. Don't forget. So we have to set a condition that once first is greater than last or equal, once first is greater or equal to last, then you have to stop. Initially, we said the first condition was when first is equal to what? Is equal to last with our previous example, isn't it? When first is equal to last, we have to stop. Also, when first is greater than or equal to last, because if you take a look at this, first is now equal to what? Is now equal to 12, isn't it? Once it is 12, we have to stop. But index 12 does not exist in this array. Then it's going to give an error. Do you know? Because we use last as length of array and not length of array minus 1. So index 12 does not occur. So we have to conclude that it is only when first is less than last, not greater, because first cannot be greater, because the greater value than last, even last, does not exist. Is that understood? So we have to write that the condition is first less than last, because first should not be equal to last. If first is equal to last at the right hand side, it writes index out of range. But if you have used length of array minus 1 as your last, yes, you can use first greater, less than, or equal to last. Is that understood? Yeah. So that was why I said you can use any one depending on how you want to write your algorithm. In conclusion, when your last index, when your last index is equal to length, okay, then let me write this as a Python code, length of array. That means you cannot use equal in the right hand side. If you use equal the left hand side, you are fine. But the right hand side, you are not fine, isn't it? Even equal means that point at which we stop. It means whenever it is not equal, continue searching, isn't it? So that means you continue searching in as much that first is what? Less than last. Is that understood? You continue searching. Once it is no longer less, what does that imply? You have to stop searching. But if you use last index is equal to length of array minus 1, you need to search, you need to continue to search in as much that first is less than or equal to last, because last index will be within range, right? But if you use this, the last length of array is out of range, right? But if you use this, the length of array is still within range. So you must know when to use less than or equal to or less than. Okay, so let's now write this code in Visual Studio Code. So this is the code. Binary search. I'm passing two things as parameter. It doesn't matter. The question may ask you to pass four things as a parameter, or even pass one as a parameter. So you don't have to memorize anything. Just understand. I am passing the array and the target. First is initialized to 0. Last is initialized as what? Length of array minus 1. Is that understood? If you have passed first and last as a parameter, you don't have to do this because the values have been passed. Is that understood? So you don't have to re-initialize first as 0 and last as something. Is that understood? You don't have to. So don't forget that according to my last illustration, I kept finding the middle value in as much that the value is not found. That means the middle value must be in the while loop, isn't it? Because I kept doing that. Good. So that means why first is less than or equal to last, because I'm using length of array minus 1. I calculated the middle index. If it is equal, return mid. Because if it is equal, once return is it, what does that imply? Get out of the function. It quits the function once return is it. It does not even go forward. But if it is not it, you check if it tends towards the right, right? If it tends towards the right, what do you change? Only the first index, as I've explained here, isn't it? If not, you tend towards the left. And after finding everything, if the target is not found, just return minus 1 after the while loop. After you have gone out of the while loop, just return minus 1 to indicate that the value was not found. You can also return, oh, it depends. Let's return not found. Why? What if minus 1 is the value in the array? Oh, sorry, we can still return minus 1 because we are only returning the index. Is that understood? Or we can also return not found. It doesn't matter. The value itself, but it is, you are finding the value, so it's not necessary to return the value. You can only return the index. That's what makes sense a bit. So if you take a look at, let's test this code by calling the function. Since it returns something, then I can write return value is equal to binary search, then array, then let's say target. Okay, let me write find. So before writing that, I should have written that array is equal to 15710 1. So now the array has been initialized. So find is expecting a value from the user, right? And I've converted that to integer. So return value. Then I have to write that if return value is equal to minus 1, that means it's not found, right? Then I can print the value is not found in the array, isn't it? So else, that is if -1 is not returned, because -1 is not a valid index of an array. Is that understood? And that was why I'm not returning. That was why I can use -1 as not found. Else, then I can print that. Okay, let me use. Okay, the set value is found at index what? Return value, isn't it? Returned value. So I need to use the format here. Understood? So with this, let's run the code and search for A4. The value is not found in the array. Let's run the code and search for A40. The value is not found in the array. Let's run the code and search for 15. The value is found at index 6, which is 0, 1, 2, 3, 4, 5, 6. Is this understood? So this is the concept of binary search.